Alright, let's continue. Let me open the table of content first. Okay, we are on chapter 6 here, and currently on homework measurement. So basically in this homework we write code to measure some aspect of operating system or maybe hardware performance too. I'm not really sure yet, but the idea behind such homework is to give us a little bit of hands-on experience with a real operating system. Okay, let me open my terminal emulator here. Okay, previously we already tried clock get rest. Now let's try clock get time. What is the return value here? Another negative one. Okay. And then struct times back. Okay. Can we make the things? Let me try. Oh, is that unique timestamp? Markup might be implement the interpretation of the corresponding time value, and the effect on timer is unspecified. Sufficiently recent version of okay. Let me add a few flags. Into this. Okay, still in. Alright. Is this nanosecond per second? Is that it? when we cast this to in. Right. Okay, interesting. Let me try this first. Oh, 0. Oh, okay. Oh, okay. Right. We need to get this again. Start time. Wait. Oh, no, not like that. Alright, it is different. I'm not sure why we use enum instead of macro here. Let's try using macro instead. I'm just curious. How many zero is this? Okay. Struct times back. Struct times back. I'm kind of curious, I guess. Oh, can I don't think I can. Yes, I cannot do that. Size of 16. Okay. Yeah. I mean, we can change this to pointer if we want to. Because again, if we change that to pointer, it will be 8 byte instead of 16 byte. Okay, more than 0. And the nanosecond, if I understand correctly, nanosecond here. Hello, ping pong poing. Welcome. How's your day? Still the same, I guess. Just learning operating system. Currently, we are on chapter 6. On section homework measurement. So I'm trying to measure, what is it called? To measure a simple system call, like reading 0 byte input, something like that. So yeah, still. I mean, I'm having fun, Learning all this new stuff is kind of interesting, I guess. So yeah, I'm trying to keep this as consistent as possible. The problem is that sometimes my internet connection down, so that is the reason I don't do long stream. Okay, let me try this. Rather than using pointer, should I just using return value? I see, I'm trying to learn new things too. I really like seeing people enjoy what they're doing. Right? I mean, if you want to learn something, it will be beneficial if we also enjoy it, Good luck for today. Don't forget, stay hydrated and eat some breakfast. I'm gonna prepare for my last exam. Alright. Good luck with your exam too. Ping pong boing. Okay. Okay, and then this one. Yeah, this is kind of interesting. The nanosecond is less than 0. Is that the question here? Oh, no? Okay. Yeah, I'm more curious about this one. Oh, where is it? But this one. When the nanosecond become negative, maybe the same thing. built a time before 1970, January 1st. Maybe. Result. What is it again? Division. Start. Make me curious to make sure what is it called? Pointer function is not no. Okay. Oh, okay. Using a sort. Yeah, that's one way to do that. Wait, I think it's not start first. Yeah, for and then start. If I understand correctly. Right, okay. And second. Why are we doing this? Yeah, I'm not sure when this condition fulfilled, and also why we need this one. And we can create a time before 1970, I guess. But why do we need to increment or decrement the second? I don't really understand yet, so as of time, I guess. Delta, okay. Okay, right. Interesting. Okay. Dot, and then dot 9, maybe something like this. Okay. One second in it. 1 nanosecond. Okay. It's negative. Okay. second general. One more second. It rains in theory. In 0 and k. In the fraction of second of the store. Oh, those are expressed in nanosecond. Okay. Let me try with this one. Okay. I think start times back. Okay, something like that. And then don't forget this one. Get time. Maybe I can combine this, I guess. Let's find out. Get time. Return value get time, okay. And then time. Time t. Okay. Oh. 20 seconds, I guess. And then start time. And time. Reset time. I don't think we don't need to save that in the struct, and we can maybe just print it out directly like this. Oh, okay, interesting. Oh, unknown time, okay. Right. I forgot to add the header file. But this is kind of interesting. If we didn't add the header file, second and nanosecond in here become integer. Okay. I'm not sure if this is accurate or not, but yeah, I assume this is what is it called? The cost of system call, maybe something like that. Hello, the unknown brother, welcome. What kind of channel is this? Well, this channel is to store my exploration video, I guess. So I'm exploring something and I do live stream of it. So that is that. If I use sleep here, okay. Add in STT. Alright. Okay. The time is different. And for some reason, is it getting faster? Not always. me check this. Okay. Let me, okay, tighten the size here. Okay, interesting. The nanosecond become negative. Okay, that's new, I guess. Okay, maybe we should add a function there. Stop times back, okay. Can we do this? I don't think we can, okay. Right. 1 line 9. Okay, this one, okay. We cannot do that. Reset time. Start and reset. And start. Okay. You know what? Maybe we can do something like this. Okay. And then for the second more than 0 and the nanosecond less than 0. Write this condition. Okay, and as per second. Let me check. Second. Call that 10. Okay. Thank you. Yeah, I'm currently learning about operating system and trying to explore about this book, the operating system, the ECPs, and currently on chapter 6 on the homework section measurement here. Trying to measure the cost of system call, something like that. Okay. Wait a minute. Nanosecond per second. Okay, something like this. And then plus I think this one, right? More than 0, but the nanosecond is less than 0. More than 0, the nanosecond is less than 0. And that is what happened in here. Okay. Okay, I'm not sure why using enum instead of macro here. That is interesting. Negative. Why do we need this? But well, let's try this out first, I guess. Reset time. Okay. So it's okay. What? Oh, right. We are not using any pointer here. Okay. Oh, interesting. That make me curious. What happen if we don't do this? Do not decrement the second. Okay, it kind of, it then take, I guess, with the time comment. Interesting. Okay, around 1 second. Oh, okay, that's interesting. Oh, okay. If we are fast enough, the nanosecond become negative. Interesting. Alright. Okay, let me try this again. I mean, an exploration, right? This one. Let me try in Python. Oh, okay. Oh, alright. Interesting. See, not sure when. Give the credit here. But it will become negative at some point, I guess. Right. And to finish operation. Hello, copy. Welcome. What are you doing? Well, I'm currently reading this book called Operating System 3 Easy Base. Let me copy this in the chat. You can also take a look at the description. I put some resource there. And currently we are on chapter 6, Mechanism Limited Direct Execution. And currently I am trying out the homework measurement here. I'm trying to measure the cost of system call, something like that. Oh yeah, for what is it called? For context, this book is about operating system. I want to learn more about how operating system works, so that's why I read this book. So yeah, currently we are exploring about measuring the cost of system call, something like that. Okay. I think I will commit that. Okay. Chapter 6. Yeah, we haven't got into. We haven't tried out this one, measuring the cost of context switch. Yeah, let's commit this first. Okay. of make me curious. A better constancy. When to use macro or enum? I mean, when using macro, as far as I understand, it's like a text substitution, something like that. We can try this one. See, it become, we substitute the macro ns per second, nanosecond per second, with the value here, right? And CPP in here is not C++, but it is the C preprocessor. I usually use this to check the macro expansion correct or not. A macro preprocessor. A macro processor. Just a little bit of information there. Okay, well, this is one way of doing things. But if it is only one, oh, it is legal to have a comma after the last item in enumeration list. Okay, interesting. But can we do that in struct? Let me. Not that one. I think this one. Oh, right, I forgot. Struct using semicolon. Okay. So we can use the trailing comma in enum. Is that it? Okay, interesting. Alright. So maybe the one that I can use trailing comma is in the function argument and struct. Maybe let me try that out. Retract. Okay. Oh, we can use trailing comma in thread. Okay, interesting. Alright, so maybe only in the function argument that we cannot use the trailing comma here, something like this, right? Interesting. Okay. Example to measure which is called trying out how to measure or another system call. Still not sure if this is the correct Any reason you are not using any type of AI for the talk and question? Well, the search engine already enough for me, so that is why I don't use AI. I mean, again, AI can hallucinate, right? And I am not sure if the answer AI give me is real or not. Something like that. I mean, the point is that it is kind of hard to validate the AI information, at least with my current experience. So I just use the search engine and checking out the manual page or the documentation, something like that. Let's see how it goes. Okay. Now measuring the cost of a context switch. Running two processes on a single CPU. Again, I'm kind of curious. A single CPU means that a single hardware CPU or a single core in the CPU. I mean, modern CPU now have multiple core. So yeah, that's I'm still not sure. The unique pipes between them. A pipe is just one of many ways processes in a Unix system can communicate with one another. The first process then issues a write to the first pipe and waits for a read on the second. Upon seeing the first process waiting for something to read from the second pipe, the operating system put the first process in the block state. Okay. I think this is easier to do with the parent and child process using fork. I mean, I already done that. Maybe something like this. Fork and then using the pipe, right? Makes sense. Bye. Okay. See you next time. Copy. And switch to the other process, which read from the first pipe and then writes to the second. Okay. When the second process tries to read from the first pipe again, it blocks. And thus the back and forth cycle of communication continue. Can try to recreate something similar here. Again, how do we measure this? Are we just using the same thing but what is it called? But inside of its process, you know. Well, let's continue this on the next session. Yeah, it is a little trickier. Measuring the cost of context switch. Okay, so that's it for now. Thank you for watching and see you next time. Bye bye.